As we will be resuming the session. ఏంటండి? ఇక్కడ మాట్లాడు.
స్టార్ట్ చేయనా? So, welcome back again. Next session we'll try to continue with tools and libraries in the spatial data modeling domain. What are the popular tools and what are the libraries that are suitable for this spatial data handling? So I will showcase some case studies. What kind of case studies have been carried out using these tools in the real-time industry. So those case studies I want to showcase. So especially for the students who are doing this, undergoing this year for your internships or your final case studies. No, I request to note down all these tools and then try to go into your or some sort of problem statements, so you can have from the next 2 slides. So there are many tools spatial data modeling, it is a very interesting subject rather than, as I told, multidisciplinary. So, individual computer science and engineering, okay, this is a subject where you deal with the software engineering, okay, development of the case studies, development of the projects using the software engineering models. But when you integrate different case studies, or when you integrate different disciplines into these models, interdisciplinary subjects, okay. But core will be the CSE only, but the data inputs and then the problem statement will be deals with the spatial data model. So these tools play a very major role. What is a tool and what is a library? Can somebody define what is a tool and what is a library? For example, Oracle is a tool, I will say. Okay, Oracle has the ability to, okay, handling this information. It is nothing but a record keeping system, okay, whose overall purpose is to maintain the data, and who is facilitating to, okay, retrieve the data, and we are able to project the data, we are able to present the data. Okay, all these functionalities are available in the Oracle. So tool is available. So I am able to apply the DBMS concepts into the tool. Facilitates all the functions in a ready-made fashion. Okay, the company or the organization is building the tool to provide you the facilities in a ready-made fashion, already existing fashion. So it is easy to retrieve the information, it is easy to handle the tools. For example, testing tools, there are many testing tools, okay, functional tools or the optimal path or some types of so all these functional tools, they provide information ready to handle it, ready to, so the tool will reduce you the time to execute your project. But whereas libraries are generally open libraries. Libraries are a particular routines. So you need to develop your own application in the similar lines of tools. Libraries are the open libraries where you have to understand the concepts, and then you have to build your application, and then you have to develop your tool on your own. Okay. Library is a little bit generic. For example, GDAL is a library, Shapely is a library, GeoPanda is a library. Whereas ArcPro, QGIS, MATLAB, Ilvis, Eridas, okay, they're all tools. Tools are the application tools where you already developed this tool for the sake of your application requirements. Okay. Sometimes in the tools, the open the codes are not available. The programming codes are not available. Right? Sometimes they may be proprietary. ArcPro. ArcPro is a tool from the ESR, very popular tool, but which is a proprietary. Really see the code, what is behind in the tool. Okay? But QGIS is a tool, but it is open source. The tool available to see the code, and if you want to add your own customization, or you want to append the code, or you want to modify the code, or you want to add your own ads, so that kind of provision is available in the QGIS. The difference between the first and second is ArcPro is a proprietary tool where they have already built the tool and they have given to the public and then the people, so which is a closed one. You cannot access the code, called as a proprietary tool. Whereas this QGIS is an open source platform where you can use the tool as it is, or you can add on your functions, you can modify the existing function, you can develop your own function. So that kind of flexibility is there. So that's why QGIS is more flexible, or in the sense open source tools are more flexible. So you need not to develop from the scratch. Okay, you can add your own function so that your function will become the flexibility to get there. So that is a development of the add-on tools. So it is an incremental model. Similarly, MATLAB is a tool where it is popularly meant for the mathematical model. Okay, mathematically has a very powerful libraries, mathematically very powerful libraries. Whereas initial ArcPro or QGIS, they are basically GIS tools, popular GIS tools. Okay, functions are available many, but mathematical models you can see from the MATLAB. There is one more tool called as statistical tool called as R, simple R. If you type R spatial tool, R is a tool which is an open source tool, very powerful statistical analysis. Suppose somebody is studying statistics, somebody is want to apply, so you can directly make use of a R tool, which is again a special one with open source. You can access code as well. Okay, MATLAB is a proprietary. Similar to that, there is a tool called as R, or you can simply type spatial R. So the examples why I am giving you is, you have to choose appropriate tools for applying your applications. Suppose I am doing a mathematical modeling, for me MATLAB will be better. If I am doing a GIS and remote sensing, so QGIS will be a better one. So you have to understand what is the tool, what is the convenient tool for me to utilize my application development. Okay, like that ILWIS also open source tools, integrated land and water information. So this is basically a open source tool that also you can go through. And then ENDAS imaging. ENDAS is a remote sensing software or image processing software. I hope most of you are having image processing, the subject also in your image processing or image graphics. No, you have subject. So for studying all these image processing techniques, image enhancement techniques, so this ENDAS imagine software will be very good. Okay, and one more tool is called as a Postgres tool for application of the DBMS logic. Okay, database management system, spatial data. So Postgres SQL will be the best tool for the open source environment. Anyhow, you have a Oracle database and etc. proprietary one. So please understand these tools. Search in the internet domain, so you can get the direct links. Tutorials also, you will get many tutorials in the public domain. Now, tools are some other libraries. Libraries are many libraries are there. You have C libraries, you have C++ libraries, Java libraries. Okay, so many libraries are available for the languages. But in particular, why I am telling is Python libraries. Python library is again open source. Python library will support many application tools. It's also one of the latest developmental aspects. No? It is a very demanding tool, library where people are using mostly in the industry. So try to get some knowledge about Python. I hope you have already in your curriculum. So try to get these libraries. I have written some popular Python libraries. Okay, mostly these libraries are very much useful for you to get acquainted with your internships or you can final projects. Also some sort of placement point of view. So please go through all these libraries one by one, and also you can try to implement in your projects. In addition to that, I am just giving a limited information. So any other tool also is almost it's good only. Try to see these tools. Now, in the next 30 minutes, what I will do is I will try to showcase you some case studies from where the project is implemented and what are the technologies being used, what is the methodology, what kind of algorithms being utilized in this application. I will try to cover one by one. There are some 5 case studies. So case study 1 is land use land cover classification. The land use land cover classification, so this is a generic image where the land I have classified this built up agriculture and then the water. Okay, so all these information. So all the green is this one, and then the red one is built up, or we can say settlements. Okay, this yellow portion is the agriculture. Okay, this deep blue, it is a water bodies. So the kind of algorithm classification is done in this one using the Python language. Similarly, case study 2, So we have developed a case study. We have done a project called as landslide the detection. Some of the hilly regions, no, in the northeast, and then the part of Uttarakhand region, and then this Maharashtra region, no, we have frequent the landslides occur. So this is what the yellow portion is, the landslide detection. So we did a case study to detect the landslides using the deep learning technologies, DL models. So machine learning we have refined further, and we have trained the model using this landslide samples. We have trained the model with some thousands of the landslides which are already occurred. Accordingly, model is trained, and then these are the predicted models, predicted landslides, yellow portions. This is actual landslides which are occurred, but this model is able to predict the corresponding the landslides occurrences. So this is done in the automated way. So the technologies being used in this project is, we have used this DL models, deep learning models. Okay, so we are using this unit model. Unit model, you understand? So there are different models in the deep learning. Okay, unit, Vjit, so many models are there. So we have taken a unit model, and we could train this model, and then we can iterate these steps into a number of iterations, and then we have provided this learning, and then the model is able to detect these landslides. The accuracy is nothing but some 60 to 80% the accuracy of this occurrences is there, just to compare actual versus the predicted one. Okay, so this is kind of application the industry is looking for. Forget about the landslides, but anything, prediction of a features with reference to the machine learning or deep learning or some sort of artificial intelligence. So the model is ultimately key to the any application. Okay, if you are able to train the model using your labels, or sometimes called as sample data, or sometimes also called as the input data, training data. Okay, generally people call them as a label data. So if your label data is perfect, if your label data you are able to clean pre-processing environment, then your model behaves very accurately. The success of the model becomes more accurate when it is more, precise. In the Raigad also, in the Maharashtra, similar sort of exists. Application is same, but in study area we have changed. This is the predicted landslide models, which is compared to this actual prediction, actual occurrences. Okay, you can understand this the correlation assessment. You can understand. Next, case study 3 is crop classification. So subject the case study 3 contains not only the crop classification in the outer way. One, what I did is, here if you understand, if you see here, the yellow portion is agriculture. Okay, agriculture is nothing but vegetation, agriculture pattern. But within the agriculture again you will have a different crops. Okay, so in this case study we have taken complete this yellow portion divided into agriculture, but the department need further refinement about the crop classification. Okay, so these are the crop classifications. So how many crops are there internally, and what is the area of that crop, what is the production, all these things will be estimated from this. Next, this is relatively easy but a very controversial subject. Water bodies delineation. Okay, water body delineation, we can do the segmentation. Okay, segmentation in the sense pixel wise we can classify, or you can do the segmentation wise you can classify, or you can do from the artificial intelligence as well. But only thing is, training of the data is very much important. So this is a very bigger feature, so that's why you are able to classify easily. But smaller values, smaller features also very much important. So you are able to Further classification to this water bodies is ponds and tanks, smaller water bodies, which are in the size of some 1 hectare, okay, half hectare. So these kind of features also will be very useful. All case studies are directly showcasing you the feature extraction. Feature extraction in the sense geographical. Okay, so there is no mathematical modeling here. Only thing is DN values. Based on the DN values, based on the feature type, you are able to refine the features, and also you are able to extract whether it is a pixel wise or it is a model wise or it is a some kind of algorithms values. Okay, but relatively easy. The next case study, what is many mathematical models are there, scientific models there. So there is a model called as Vjit model, which is called as a variable infiltration capacity. Okay. Also one of the popular model where, so these are the outputs: precipitation, evapotranspiration, runoff, soil moisture, and forecast surface runoff. So these parameters are basically scientific parameters, and the model is calibrated using Vjit model. Okay. Don't afraid of this Vjit model, these outputs. But generally, I am telling about how this model is calibrated, how this model is automated using the Python only it is done. So now the model is methodology is like that. The model is inputs are collected from the CDAS in a cloud platform with parallel processing. Output is aggregated and then in the geospatial format. Output is disseminated or given to the user department in the form of a web services. Okay, you just see the methodology perfectly in the CS language only, right? Model is deployed in a cloud platforms. But before that, what is this model? I am not telling you the model, the formulas and etc. I am not telling you the model, the formulas and etc. There may be many models, many formulas, but ultimately what I am doing is I am just customizing this model using a cloud. Got it? Think that this model is just a generic model where you have n number of inputs, processing and output. Example, C equal to A plus B. A plus B is my model. Okay, that model is able to provide these 5 outputs. Precipitation in the sense daily rainfall, daily evapotranspiration, daily runoff, soil moisture and surface runoff. So these 5 products we are able to daily do in an automated way for me. So okay, 5 o'clock to 6:50 for entire India we calibrate this model, and then we will deliver the products in a real time to the Government of India, Central Water Commission. So this is a purely a mathematical model. So you see the product for entire India it will come every day. All these 5 products every day you will get in a automated way and will be disseminated to the Central Water Commission. So this is the complexity also. I meant to say the complexity will increase when you incorporate the mathematical models. Okay. Earlier the geographical features very simple. Water body DN pixel you will extract and then you will provide. You will save and then you will try to disseminate. But here there are many mathematical models. I am not telling you the mathematical model. So if you require more details about that one, you search Vjit, variable infiltration capacity. This is the model name. In the model name you can search, you will get lot of all these input parameters, all these things. But thing is, we have customized all these model parameters in a methodology. Next, one more mathematical model called as SWAT, Soil and Water Assessment Tool. Soil and Water Assessment Tool also one of the tool where we have customized and then we have developed in the similar to the Vjit model. This also provides 6 parameters, 6 products on a regular format. This model you can see very interesting model. Did you hear about snow melt? in the Himalayan region, we have a huge deposits of the snow. Okay, so every day, particularly in the peak summer seasons, around March to the around June, July, so there will be a snow melt. So this is the study where we are studying the snow melt products under forecast of a particular snow melt on a summer season. So this model also we have developed. So methodology is like this. So daily downloading of the data, pre-processing, performing the spatial computations for this snow melt runoff, and then the transfer of this snow melt. So the snow melt is a ratio, is a rate. How much snow is melting in regularly, and also forecast mode also. Coming 3 days, how much it is going to happen. So this kind of the forecast is also given in this model, and then it is again a very big model. So somebody can search SWAT model, mathematical formulas you can search. What we did, the complete mathematical model we have customized in this algorithm. The algorithms we have computed, and then we have developed in a cloud computing format. Next, one more landslide. Previously I have shown you the landslide occurrence, but this is nothing but the landslide predictions. Prediction in the sense early warning. So next 3 days, whether landslides, there is possibility of landslides in the particular route. We are not doing for entire country, but particularly for some regions, Uttarakhand and then the Kedarnath, Badrinath. So this is the route. So in this route, next 3 days, is there any possibility to happen the landslides, any occurrence of landslides possibility? So this is also one of the interesting study where there is a landslide possibility or probability based on a rainfall using the regression equation. So this is the equation. Please see this equation. Okay, this is a statistical equation which is a regression formula. It's purely based on the rainfall, because landslides is directly proportional to the rainfall, the intensity, along with some parameters are there, slope, aspect, okay, and also the elevation, right, and the slope is important. So these things are customized into the mathematical model, and then input data has generated the landslide early warning system. So you can see this red, yellow, green. Red means probability of occurrence, yellow means less possibility, green means there is no warning. So that in this region there is a possibility of occurrence of a landslides. This is basically purely a forecasting the mode. So which is not actual the scenario. It is a forecast, 3 days forecast. Okay, so the forecast is computed using this formula called as triggering probability based on a rainfall. Okay, so just I want to impress you to just see this formula. DR is the daily rainfall here, 3D cumulative rainfall for 3 days. 30 DAR is nothing but the rainfall which is happening in the last 30 days. Okay, the average of the rainfall for the last 30 days. So all these things were computed in a real time, and then only the data is, so this is the latest data. Suppose the rainfall means today's data. Okay, 3 days cumulative, previously 3 days, 30 days, last 30 days average. So these kind of inputs are directly processed and fed into the model, and then the model is deployed for the rainfall early warning system. Again, one more model which is popularly known as evapotranspiration model, which is called as Aicte. Evapotranspiration model, which will be used for the water balance models. So there are 2 products, Aicte evapotranspiration, and then also some more models are there which are potential evapotranspiration models also. So this is what the methodology. So morning 6:15 it will run, and 9 o'clock it will generate the products for entire India. Evapotranspiration, this is a process, which is a process for estimating the evapotranspiration parameters, which is a purely a water resource subject, a civil engineering or a water resource subject. But thing is, the background entirely this related technology is being used, customization of the model, deployment of the model, and also the hardware, the servers and then the storage also being used, lot of computational activities also being used. So entirely the AIT is programmed here, and then products are being generated. Last one. So this model is assessment model. So possibility of the occurrence of the drought of a particular region. Drought is nothing but non-availability of the rainfall or non-availability of the groundwater. Okay. How did they confirm? How did they compute it? So there are two indices for that: standardized groundwater index. Standardized, this is based on the groundwater depth. If groundwater table is depleted or some sort of deficiency, this model is better one. Standardized runoff means rainfall based drought. Okay, non-availability of the water or surface water up to some level, so they will declare it as a drought condition. So these two conditions also have been calculated. If you see this groundwater is measured directly from the identified sample wells. Here it is based on the rainfall conditions. So it is for 30 days, 60 days, 90 days, 180 days, 365 days, and then like that it will be calculated. So yearly number of years, even 40 years rainfall also sometimes we calculate for the drought scenario. Sometimes 100 years the past historical data also being calculated for this drought scenario. So ultimately drought scenario is the variability of your water availability or surface water availability based on compared to the last 40 years to 100 years. So with the comparison, generally people makes this drought assessment, drought conditions and drought prevailing conditions, and also the prediction conditions. So all are generically real-time problems, particularly the different thematic disciplines. But only thing is applying your mathematical skills along with the coding skills for customizing these models will give you the results. Okay. Objective is customization or development of a particular model with reference to the requirement from a discipline, maybe a land use land cover discipline or a water resource discipline or from a traffic discipline or from a health discipline. So many disciplines are there. So models will be many more models. Who will give the models? The corresponding expert will give you the model, and your responsibility is to automate, to code it, to develop the model, and then execute this model on a infrastructure, computing infrastructure. So with this, I will just close it. But in the previous 10 case studies, what are the important steps? You will say algorithm means is a step, series of steps. The step one, what we will do is, we will do the data preparation. Data preparation in the sense, we will prepare the data preparation which are required for these data sets. Step 2 is data pre-processing for integration of the data sets, because all are heterogeneous data sets means your model will not work. So you have to clean your data, pre-process your data to bring down to a uniform format where you can work on your model. So that is called as a pre-processing model. Third one is apply your technologies, whether you are applying event processing, classification, segmentation, or sometimes machine learning, or sometimes deep learning, whatever the model you can implement. So this is the core of your subject. Fourth one is the data classification, and then once your data obtained output, then you post process it as per your requirement of the template. You will do it, and then also you will validate your data, whether the generated data is precise or any mistakes are there or some false positives or false negatives. So you will do the data validation and then execute all software models for your application in a faster mode. So we are using some GPU enabled cluster so that the model will happen fast, because every day we have to generate models. Before 9 o'clock we have to complete the task and we have to upload the products in a ministry websites. So we have to accelerate our processing speed by using computational technology. So since now GPU is one of the models, GPU is one of the card, so we are using the GPU technology for the fostering your applications. Okay. Now, what are the resources available for this data analytics or data science, or you can say machine learning, artificial intelligence? Okay, many aspects. These are the useful libraries from the data science. So most of you are already aware. TensorFlow, how many of you are aware? So TensorFlow is one of the platform where you can develop your machine learning models. Keras also you can do, PyTorch, okay, and also classification models like CNN model, ResNet model, okay, and B is the important model where we have worked most on the unit model. You can use MLP unit, whatever the model you like, and then object oriented model also you can do it, YOLO, and then the CNN, etc. So all these things are very much latest technologies or latest libraries which are available in the open source. Okay, you can pick one of the models and then you can try to customize your application using the. But only thing is data is the main critical point. So data has to be there in the your systems. So you can try to capture the data and then try to do it on the libraries. So any questions?
Suppose if we have a landslide at West Bengal and they have considered those factors and created a model. And if there is a situation like the same landslide in a different way, it may occur in Kerala also. So can I use the same model? Definitely I can't. So this is an unpredictable situation. So do we need definitely a field investigation there? What are the factors I should consider in order to define it?
Yes, madam. See, these landslides, no, they are very precise and specific to the study area. So the landslides in a generic way, landslides occurring in northeast, properties or parameters are different than the landslides that are occurring in the western Ghats, like Maharashtra, Kerala, or the Karnataka. Okay, so the parameters are different, the weightage patterns are different. So in this study what we did is we have developed a model to the individual study areas. So as a whole the model is ensembled models. All these areas were developed individual models and then complete models are assembled so that you can deploy the appropriate model to the particular study area. So if I am deploying the Uttarakhand related model for the West Bengal, the precision is very less because the terrain conditions are different, the hyperparameters are different, and samples also different. Of course, the parameters are same, but the weightages are different. Somewhere you have given a weightage to the slope, somewhere you have given a weightage less. So the model you need to develop for a specific study area and then deploy only because you are doing a validation also to that model. So generic models are very, very difficult, like landslides, but in the conditions of a crop area, so because it is a uniform pattern, so it is valid for the entire study area, entire country. So in that way you have to balance your models when you are applying to a study area specific problems. Also you can internship level, so you can think about your some of these case studies. Okay, you can capture these case studies in these open source libraries. Okay, you can develop a small case studies for maybe 2 months, 3 months, so that you can experiment on your own that how it works. Okay, only challenge for you is the data. So try to get some data from the open source platforms. Okay, so you can also contact your faculty for the data sets, so that you can have some 3 months the internship studies to just see that whether the models are working or not. At least the model deployment is happening or not. Okay.
Sir, I'm having one query regarding what you discussed in this. So, on the part of accuracy of modeling, so how do you evaluate how accurate the model which we have developed? What are the different processes?
Sir, actually, when you are doing a model, the deployment, you have 3 parameters: precision, accuracy, and recall. Okay, I think you have this is what the core of the data science. What is the precision rate? What is the recall? Okay, so all these things will form a strong base. These statistics only they will see these 3 statistics. What is the accuracy of your model? So the model accuracy always depends on the kind of input samples you are using, the kind of parameter you are using, the kind of hyper parameters tuning you are doing. So all these things will be mattering a lot in your application. So sometimes it may be 50%, so model is not very accurate. Sometimes it is generally 70 and above, they will treat as a okay model. So always try to improve the model by using your hyperparameters, so that your model get more accurate. So there is no hard and fast rule that this much percentage is good, this much percentage is bad. So depending on your type of features you are doing, type of forecast you are doing, type of analysis you are doing, so that will define the accuracy or success rate as per your requirements. Okay. So with this we will stop this one. So I think the PDFs are available with your HOD. Okay, so you can share your things. So any details further you can always speak. Okay. Thank you very much. See you all the best.
A heartfelt thank you, sir, for such an informative and engaging session. Your ability to simplify complex concepts and relate them to real-world applications in spatial data is truly commendable. On behalf of all the participants, I extend our deepest gratitude to you for sharing your expertise and experience with us today. The insights gained from this session will undoubtedly serve as a valuable resource in our academic and professional journeys. May I now request Head of the Department and Coordinator of FDP, Dr. Anusha Ma'am, to felicitate our guest speaker, Mr. Rammohan Rao.
First call everyone. You should call everyone here. Hey, Randa, it's fine. That server's there.
On behalf of Vjit Management, Department of Cse-Aiml, I would like to extend my thanks to Dr. Ramohan sir for accepting our invitation and sharing his valuable knowledge with us. Thank you very much, sir. I request all the participants to go for the lunch break. The afternoon session will be resumed at 1 o'clock. Thank you. The same venue.